Good day, folks. This is the first of 3 videos in the first lesson while I'm away, the one on curve sketching. I've broken the lesson down into 3 separate videos, each with a bit of exercise at the end to make it easier. So we're going to be doing some curve sketching, or much the same as you've had in the normal lessons: intercepts, local maxima, minima, increasing, decreasing, concave, points of inflection. We're going to be using those, and then we're going to add one extra aspect to it. Clearly these graphs will be more complex than the ones you did in maths class. So here are the steps. You need to determine the x-axis, the axis intercepts. You often are expected to use Newton's method for the x-intercepts. Determine the values of x for which the derivative is equal to 0, because that'll give you the stationary points. Substitute these x values into the original function to determine the y values of the stationary points. Substitute these x values into the second derivative. If the second derivative is greater than 0, then that means a minimum because it's concave up. Less than 0, maximum. But thirdly, if it's equal to 0, it doesn't give you enough information. So you have to test the function's concavity before and after the stationary point. Remember that a point inflection need not be a stationary point, as it's only a point at which the concavity of a curve changes. So often it's advisable, you'll find I do that in these examples I'm doing with you. I find the stationary point first, because then I can use Newton's. It'll help me find an estimate for the use of Newton's method. Right, here's the first example. Pretty straightforward cubic, but you need Newton's method to find the irrational x-intercepts. So let's go with the stationary points. Derivative equal to 0, and we're going to solve for x. So we now have the x values of the stationary points. We're going to find what the nature of these stationary points is. So I find a second derivative, and I'm going to substitute each of these into the second derivative to see whether they give positives or negatives. So at x equals minus 1, if I substitute in, I'm going to get a negative. You don't need to show the actual value, you don't need to show the working. And therefore there's a local maximum at minus 1, 5. I've been naughty, I've really substituted that into the original. It's better to actually show it usually, but that's where that 5 comes from, substituting that into the original. And it's greater than 0 at x equals 3, so we have a local minimum at 3 minus 27. Y-intercept 0. So now, there's my information so far. Now I'm going to put it onto an axis. So there we are. I'm going to put the 2 stationary points with their nature, and I'm going to put the y-intercept. Now I can pretty much estimate where this graph's going to go. I know it's going through there, but here it'll come down here somewhere, and there it's going to go up and hit over there somewhere. So I sort of estimate. So it's about -1,8 and about 4,8. Doesn't matter if you're out, because as long as it's on this side of the stationary point, actually, wherever you go, even if you choose a value just beyond -1, like -1,1, you'll end up with the stationary point anyway. So there we are. There's our Newton's method, or Newton-Raphson method. So now I'm going to use an intercept, substitute the intercept in to f prime a, f of a, and to obtain a new estimate. So there is the original function, and there is the derivative. Substituting in the values, we end up with -1,9. Now, in graph sketching, you can't do pretty much more than one decimal place, because on a smaller scale, I guess if you have a bigger scale, you can go perhaps 2 decimal places, because it's very difficult to put more than that. Imagine trying to put 1,89438 onto a graph. Well, it's 1.9. Right, so there's 1.9, -1.9. So I'm going to repeat the process. I'm going to do exactly the same thing again with -1.9. There it is there. And we end up with -1.9. So I say, yippee, I have the same value coming up, so I'm going to keep getting that same value. Please remember that when I substituted this -1,8, and I got -1,9, I keep the whole value on my calculator though, and put it into my memory bank, because I use that while I've only got -1,9 here. I'm really using the full number obtained in there, just for accuracy. So we know now -1,9. So we can now label that there. Now I'm going to do the same with the 4,8. Substitute into the formula, and I get 4,9. Substitute again, and I come up with 4,9 again. So now I can take that and put it instead of that approximation there. Now we're ready to sketch the graph. And there we have it. And that's the end of the first video. Now you need to go to the exercises, the curve sketching 1 exercises sheet, and do question 1.